to the second session with Ausbildung. Today we will solve few numerical. Yesterday we saw circuit elements and we calculated the power and energy across the inductor, resistor and capacitances. So based on those topics we will solve few numericals that will be important from all the competitive examination point of view. So let's begin with the questions. Begin with the first question. A 100 ohm resistance is directly switched on across a 10 volt battery. What is the current through the resistor? How much is the power loss? Also find the energy consumed in 5 seconds. So let's draw the circuit. So when we will draw the circuit, so here we will get 10 volt battery is connected across 100 ohm resistance. This 100 ohm resistance, so current here will flow. We are assuming at I, so I is equals to V by R. So here voltage is 10 volt upon R is 100 ohm. So here we will get 0.1 ampere as a current. Now second question is power loss. So power loss across resistor is I square R. So here I is zero point 0.1 whole square into R is 100. So here we will get 1 watt. Third is energy across the resistor, that is equals to I square RT, or energy consumed by the resistor, that is equals to I square RT. And here I square R is 1 watt. So here directly we can take power here, and T is what? Time is 5 seconds. So here we will get 5 watt second, or you can also say 5 joule. So I hope this question you all have understood. So moving to the next question. The second question is saying the strength of a current in 1 Henry inductor changes at a rate of 1 ampere per second. Find the voltage across it and determine the magnitude of energy stored in the inductor after 2 seconds. So here question is saying L is equals to 1 Henry and di by dt is equals to 1 ampere per second. So now we know that VL is equals to voltage across inductor is equals to L into di by dt. This I have told you all in the yesterday's session. If you all have not gone through those sessions, so you can find the link in the description box. So here L value is 1 into di by dt is 1. So we will get here 1 volt. So next is energy that is stored in the inductor. So it is given as W is equals to half into L into I square. So here I we will find as I is equals to di by dt into time. So here di by dt is 1 ampere per second into time is 2. So this will give us 2 ampere. So here we will substitute those value. Half into L is 1 into I is 2. So here we will get as 2 joule energy. So 2 joule energy is being stored across the inductor. So moving to the next question. A capacitor has a capacitance of 5 microfarad. Calculate the stored energy in it if a DC voltage of 100 volt is applied across it. So here it is given V is equals to 100 volt, that is DC voltage is 100 volt and capacitance value is 5 microfarad. So micro is 10 raised to the power minus 6. So we will get here 5 into 10 raised to the power minus 6 farad. So energy, we have to calculate the energy that is being stored in the capacitor. So W is equals to half into CV square. So here half into capacitance is 5 micro into voltage is 100 whole square. So here we will get 2.5 into 10 raised to the power minus 2 joules. This is the stored energy across the capacitance. Moving to the next question. So the current and the voltage profile of an element versus time has been shown. Determine the element and find its value. We have to find the element, whether this element is inductor, resistance or capacitance. So we know that voltage across inductor is given as L into di by dt. So here it is saying when we will differentiate the current, so we will arrive at the value of the voltage in case of inductor. First of all, let us check with the inductor. So here we are seeing current as a ramp function. So when we will differentiate this ramp means we are differentiating the current. So here differentiation of ramp will give us what? Step function. Okay, so you can see here differentiation of current is giving us voltage. So differentiation of ramp function is giving us a step function. So this is definitely inductor. So this element is a inductor. So now we have to calculate the value of this inductance. So we know that V is equals to L into di by dt. So here V value is 2 is equals to L is what? L is not known. Di by dt is 1 upon 5 milli. Here we are getting L is equals to 10 millihenry. So here value of inductor we have received is 10 millihenry. So moving to the next question. So here it is saying the voltage time profile of a source to charge a capacitor of 50 microfarad is shown in the figure. What is the charging current? So it is asking about charging current. So we know that charging current across the capacitor is IC is equals to C into dV by dt. So here we are getting IC is equals to C into dV by dt, and here it is given as dV by dt from this graph is 20 upon 10 milli. So this will give us 2 into 10 raised to the power 3 volt per second. So now we will substitute these values. IC is equals to C is 50 micro into dV by dt is 2 milli, no 2 kilo, that is equals to 0.1 ampere. So this is the value of charging current. Hope you all liked the session and understood each and every questions. So please like, share and subscribe this video and press the bell icon. Thank you. Meet with the next session.